Good evening everyone, I am Mr. Rich. You're joining me for this video here on lever problems. Just because we're looking at this word lever, it does not indicate that we're talking about physics. While it might give the hint of physics, there is algebra component in it and it is a good word problem type to understand. The basic aspect of lever problems is no different than a seesaw. You have a fulcrum and you have people, one or two on either side, sitting on this seesaw, and you have to try to do an adjustment such that the lever or the seesaw remains flat. It does not tip on either side. And you have a person with a certain weight on one side and a person with a certain weight on the other side, and you have a certain distance from that one person to the fulcrum and a certain distance from the other person to the fulcrum. And the basic format over here in terms of solving these out, you have weight 1 d1, person 1 certain distance from the fulcrum should equal person 2 in terms of weight and a certain distance from that fulcrum, and this right here is the form you usually take. A heavier person usually is closer to the fulcrum and a lighter person is further away from the fulcrum to make this balanced or flat so it won't tip. So remember this as we do this next question. Our first question is this, let's read it out. We have a certain person A, and that person is 90 pounds and positioned 4 feet from a fulcrum on a seesaw. We have a certain other person B. How far must B be from the fulcrum to balance that seesaw if B is 110 pounds? It sounds rather easy. If you just remember that formula, we can even draw it out. We have a certain fulcrum over here and A is right over here, 90 pounds, and is positioned 4 feet from this fulcrum. Person B should be positioned a certain distance. We don't know how much that is, but we know that person B over here is slightly heavier than A. So person B must normally be closer to the fulcrum. The lighter person should be slightly further away. How can we go about doing this? Just remember the formula. W1 D1 is equal to W2 D2, and that's exactly what we need over here. W1 90, D1 4, W2 is 110, D2 is an X. Solve for this X. You'll have 360 divided by 110, and that right there will give us our answer. And we get 3.27 feet. So person B must be 3.27 feet from the fulcrum, so slightly closer, and person is slightly further away, and this fulcrum will be balanced. It will be flat right over that fulcrum point. This second and last question for this video will be interesting, slightly challenging. Let's read it out. A is 170 pounds, person B is 130 pounds. If they are sitting on opposite ends of a 15-foot plank, how should the fulcrum be positioned to maintain a level or flat orientation? Meaning, how would you position the fulcrum from either ends of those two people so that the seesaw is not tipped at either end? The best way to approach with this question is to draw it out. Here we have a fulcrum. We know normally the lighter person has to sit further away from the fulcrum and the heavier person is sitting closer to the fulcrum to balance it. We have the heavier person right over here and the lighter person being further away. How do we go about doing it? Person A is heavier, so that person will be sitting closer to the fulcrum, or the fulcrum will be closer to that person. Person B is lighter, 130 pounds, and so the fulcrum will be further away because a lighter person has to sit further away from the fulcrum to balance it out against a heavier person. We have to find this distance and we have to find this distance because it says how should the fulcrum be positioned. If you know that the entire length is 15 foot, how can we split 15 feet algebraically into two components? Well, if one is x, the other one must be 15 minus x, and there, right there, gives us everything we need. Weight 1 d1, weight 2 d2. So we have 170 times x is equal to 130 times 15 minus x, and you just have to do this computation. You have 170x is equal to 1950 minus 130x. 300x is equal to 1950, and x is equal to 6.5 feet. What does that tell you? This right here must be 6.5, and this here will be 8.5, which is 15 minus 6.5. So person A, who's heavier, will be 6.5 feet from the fulcrum, and person B, who's lighter, will be 8.5 feet from the fulcrum. So if they're both on the specific ends of this fulcrum, you want to position the fulcrum either 6.5 feet from A or 8.5 feet from person B, and you will have a completely balanced and flat seesaw or plank over here, and the question has been solved. So with that, we end this video. Thank you for watching. Hopefully this topic was interesting. Have a nice day.